Okay, hey, train your planets every day. Jordan Skull coming at you from the STEM lab here this morning, or afternoon. Sorry. So, it's been a little while since I've done any quantum physics homework or quantum mechanics homework for the class, if anybody wants to do it one day or what have you. Kind of been a little bit busy, but, as we know, or at least you should know by following some of my work, that quantum mechanics and psychology and physics, they run a very fine line. So I wanted to do a new quantum mechanics or quantum physics tutorial for you. Give you a new homework assignment, something to look at, and some base work to use off of my material if that helps you. So if you're new to this idea, I'll first tell you you can use my Facebook page or my YouTube. You can scroll all the way down to the bottom, and you'll see some yellow pages of PDF files of my unified field theory. There's the seed, the stem, the bank of terms, some stuff about general relativity, and then Beals, Fermat's, erodes, Fermat's, Beals, Yang-Mills mass gap, the NP problem, Brick and Seidler's conjecture, and a few other ones in that concept. And I want you to very specifically use them because those are my quantum field theories. Now, again, there's some difference. I mean, you'll have to understand some certain things. One, this is kind of about authority. I'm referencing mine in terms of this is the quantum nature of it, and we're going to talk about other people's authority and referencing why a company or why a factory, a snow code job, McDonald's, they're all their own universe, and you could say that quantum theory is going to work there and it's going to help you do what you do there. It's kind of inverted, half the problem of something else, and both states can reference the same thing. Erodes references Fermat's. A is an abruptly long sequence, so A plus B equals C, causally. You could say that Fermat's is AX, this aspect of A inside of X, Y, this term, plus this other term, will make something very specific in terms of the conversation of how you would break something down and say, well, that's a stone dock, not a quantum universe, but still quantum. And then you get to something like B's about why something specifically, and again, there's more aspects to it, but something specifically like a SAW concept or something like that, or small particles of that, and specifically look at, I have them written down here just because I wanted a non-computer base for them. But you look at them and you'll see what I did here when you read the mass gap problem later about this new fundamental aspect. Regardless of whether it's quantum mechanics and you're in NASA, their job is to break that stuff down. When you're in a stone dock, your job is to process, but basically you're processing particles. And what they are in terms of these notes and how you break down these notes. Because later on, when we will break down this into resumes, into OSHA laws, into specifically how to generalize something like a gantry saw or an arc saw or a thermal process. I mean, it's not the real deal, but it generalizes it well enough in local relativity. Not general relativity. Remember, general relativity is just going to be particles pointed all over the place in a straight line that helps you make this process flow. Because what we know to be some of the problems with quantum gravity is we need to make it flow like general relativity. And general relativity is a series of math problems that will help you determine masses and speeds and all kinds of other fun stuff that you can do with it. But if you're not that deep into it, what we can use it for is a lot of those aspects here. And here's some mathematics behind this idea of just a general second. Here's what I know standing in the second, and I could say that is the past second, meeting to where I am right now, what I know about the past. I could say that this is the present, x, y, and I could say that that's going to go into what I know about what the future second is. I'm not standing in that future second yet, that saw, this McDonald's, whatever the material may be, because later we're going to build this into a resume form, and there's lots of different forms. Remember force here. When we go to weigh a resistance, WAR, we're actually making anagrams for them. And just like survival, survey environment, utilize all your resources, and all those other, that's a quantum mechanics a question. There's a lot of different forms for them, and I'm not really particular. Like I said, later we're going to get into all kinds of different types of form states and ways to break down notes. You can make a standard general writer into, I want this product to go into this form. If it's not enough, we're going to make that same form, and at the heading we're just going to put page 1, page 2. And that's going to be an extra key state to help us understand causally by generalizing this, by general relativity, how the authority of how the eye works, how the brain works, and all that other stuff makes this function appropriately. Alright, so what your quantum mechanics homework is going to be is to start to recognize what you're standing in, your job you're doing. It doesn't need to be clock-in jobs either. It could be how you grow corn. I know that was a great one. There's a lot of divergent principles about changing the light spectrum and STEM testing. Doing one test with the light this far off of it and one off of this. They're both going to grow, but they both have very different physics. Putting this into this, calculations are going to go very specifically here, and they're going to go here. I'm not going to ask you to do the full divergent spectrum, but at least reference, you could do a STEM testing variable on time systems, on diversified inconsistencies. When I do stuff for after I do my general resume system, usually what I like to put with those when I'm doing my writer is something like throw a saw in there, do scale drawings of what that saw looks like. You could say that integrates into other aspects of that shop, so you could put down the whole shop and then say, well, when you're doing this over here, and then break it down with those notes. And if you're looking at Fermat's and Beals, you'll see that there's a name, which is quantum, or SWAG Incorporated, which is basically my fancy way of saying universal field theory. But that's 0, that's A, that's 1. Without getting into all that really crazy mathematics with you, which would take way too long to describe, you're just going to put a name. That's A, that's X, that's 1. Then you put a concept. That's A, that's X, that's 1. Name goes to X, concept. And you're going to start breaking that down with notes. And do it in a Newtonian order. Remember, this is actually a very tricky problem. Not necessarily that the process is very difficult, but to define what order you want, and to do it with enough detail that it's still special relativity, but generalized to not really being this real thing. But somebody could still causally look at it with the eye irrational number, not Murphy, and be able to make that quantum leap, or to be able to bridge that mass gap by breaking down what physics are going down here, the laws of motion that aren't exactly this inert body, but yet this very specific stone, wood, hamburger, I don't care. Like Max Planck said, when you start to look at something, it's going to change. Or paraphrasing his quote there. When you actually look at a cheeseburger, and this is one of my favorite quotes from Max Planck, he doesn't use a cheeseburger. He generalizes it. But there's a lot of different spectrum. There's a cow farm, there's a pickle farm, there's a dairy plant off of that. Think of how many really divergent principles that are going into that one element, that particle. When you break down that particle, when you expand that particle, and it begins to reciprocate into all those different fields, frames, forces. F is just an anagram by that standard mathematically that could be a gradient up, could be a gradient down, could be a negative velocity, could be a negative acceleration. You don't have to put in heavy-duty mathematics with this stuff. I want you guys to make something practical with it. Again, what I like to do is make a resume. Not only is this a great resume or a great business model or whatever you really want to break down that company to be, because you can take these standards and go, well, what I want to do with them, just by looking at it here and making that shift, that somebody's going to be able to say, hey, that person, I bet you they can make a patent design. I bet you they can make a business model because they understand the forms, they understand the forces. Obviously, there's a lot of mathematics, quantum mathematics, and elementary physics, the lowercase letters. You got to get them down, that in those forms, remember, that's going to help you set up these forms and those string equations, how you're going to write this out, not mathematically, but word for word. Remember, what we know about mathematics is that there's a quantum leap between mathematics and spelling Jordan. This is not something that the universe predestinately made out. But it gives us that option to say that, well, that's why this is what it is. Now, I couldn't tell you why my name is what it is. Bob Henry George Human, Homo sapien, American domesticated, I don't know, whatever you want to call it to be that kind of model. And it works with a lot of different languages and different alphabetical sequences, but basically in the quantum processor, there's too many combinations. They're all going to spell out, and I'll get you into some Horseman code detail stuff about actually making a code cipher to really show you what I'm talking about by trying to crack something with that many code combinations inside of it. That's a different class or a different bit of homework. But what I want you to do is basically read out those Rhodes, Fermats, Beals, some stuff about general relativity. What I describe this to be is in a general second. It's very square. Nothing really in nature comes out that square. Most times it's really globular. Even a second here. Very large, very small. Sometimes it's dealing with these details. But it has a turbulence problem. Once it hits this, it's going to affect everything. And your job is to have the reins to be able to say, I want it to close off here. I want to be able to explain it. The first step. And what we know about psychology and physics when we're dealing with students and stuff doing this in the intro is, one, just try to do an intro. You know, if you had to write that stuff out, what your job was, so somebody else could do it, that's actually a very, very hard challenge because of how many divergent principles may actually go into it, what you don't really know, what somebody else will do. But when you make a Newtonian process for it, it's easy then to say, well, I can make that process in a generalized form, your S.T.E.M general's resume. And then later on, no matter what order they come in, what kind of principle, I can just jump right to that page because number 57 is actually page 1 for this concept in time and space that we're dealing with. But you have to have that all written down, otherwise it's just all hodgy-podgy and certainly not scientific method, because it's about writing stuff down, taking accurate notes, analyzing, and interpreting those to be able to many divergent principles. Again, with the NP problem, which you'll read into some of those things, how to define a universal field theory, and something like what I'm doing recently here. I'm not doing it, I'm actually a grinder, but I eventually will for my own private study. Whether I don't know if I'm going to be able to put it up there because I signed a confidentiality thing, but I mean, it gets into marketing, it gets into physics, it gets into mathematics, it gets into psychology, you know, leadership skills, and actually, you know, just how to keep the symbiotics going. You know, sometimes it's best that you don't say things as much as sometimes you have to. Those, any point in time, those things will jump out. So like the NP problem, unifying or setting up a principle of universal field theories is actually what you're doing in a different form. You know, just to generalize it, it works great with mathematics. Here's a bunch of math theories, you know, whatever. Beals, Fermats, you know, Nova-Stroker's air turbulence problem, and existence. What is it? Existence and smoothness. That's very important. Now, they're talking about an air turbulence problem. This air molecule hitting that air molecule and the butterfly effect. How do you make that to prove that exists? So I'm talking right here. Obviously, psychologically, it's going to have an effect on you, whether you believe me or you don't. I don't believe that. Well, that's an effect. I do believe that. Ooh. Well, what effect's that going to have? And how smooth of a transition can you really make those jumps? In place, no matter what the concept I've done, you know, it's a lot of OSHA work. It's about OSHA laws. For me, aren't exactly this thing that you can generalize really well. I mean, they have a general feel to them, but for me, they're really more about Murphy's Law. After I've zeroed out all the saws, a saw goes back here, then the block or whatever, or how you set up that table, you know, that's all zeroed out. And beyond that, I'm just referencing Murphy's Laws, you know, to keep any kind of one-off principle or, you know, something that is a really dominant one-off, and then the next one would be B, which is a less dominant thing to have happen. But over at C and D and E and F and G, if you don't get that right, it's like totally going critical mass on that effect on that saw. It'll blow it up. It'll literally crash, break. But it only happens once off. So there really is no order. But to try to lay them out correctly, it takes a lot of skill. Why does somebody need to see this one first? Because it's right there. Why is that a great trainer system? How does that reference you better as a general? How are you going to write that up in your system, no matter how many pages or how many systems you do? It's going to make you look like a general. Catch you on the next one.